consider the following molecule. Are the bonds polar, nonpolar? Are the bonds polar or nonpolar? Is it just one? Yeah, it's just one molecule here. Okay. So it's I have scl6 here, and it's asking us if bonds are polar or nonpolar. And then the molecule itself, is it polar or nonpolar? So I'm looking at scl6, right? And we really care about how what the hybridization is, or what, according to Vesper theory, what kind of geometry it's going to take, right? So I have my sulfur here is going to be in the central atom, be my central atom here. It's going to be bonded to six chlorines here. So I can write this down here, but it kind of looks really messy. 1, 2, 3, 4, 5, 6, and these guys are all Cl, like so. So it really depends on what kind of hybridization this sulfur atom goes through. So as you can see in the solution here, it says sp3d2 is a hybridization. So you can think of it as we can actually Google Vesper theory if you're having trouble with this kind of concept here, and it'll tell us what kind of hybridization this geometry is going to take here. So let me just show you what Vesper theory is, or the chart here, and it shows you the different shapes it's going to go through. So let me click this link here. So as you can see, in Vesper theory, you get there's a generic formula, right? So you have scl6 here. So I'm gonna scroll all the way to scl6. So this here is our kind of compound here. We have A, which is some type of element, and the X6 is some type of you can think of it as a halogen or some type of fluorine here, or not. In this case, it'd be chlorine. Sorry. So you have this is your hybridization, sp3d2. So again, sp3d2 is hybridization, and again, in this case here we have no. In this case here, it's all bonded to again 6. We have 6 kind of sulfurs. So these, you can think of these guys here. It's a nonpolar it's a nonpolar molecule in the sense that it's this sulfur is saturated. I know sulfur here can make 6 bonds because it's going to hybridize into this sp3d2 hybridization, right? So in this case here, it's going to make as you can see, AX6 here. It makes an octahedral kind of geometry here. So this here is octahedral, and in this case here, there are no lone pairs here. So these sulfur atoms are all bonded to these chlorines are all bonded to the sulfur atom, and there's no lone pairs here to push kind of these bonds away. So therefore, in this case, this molecule here, I guess I answered the second question. This molecule here is nonpolar, because again, there's no lone pairs to make it a polar kind of compound here. But are the bonds polar or nonpolar? And if we want to check that here, we have to go to our periodic table to check the electronegativity difference between both of these molecules here. And as you can see, you have sulfur and chlorine here. Sulfur and chlorine, they're very, very close in terms of electronegativity. So in this case here, there's a difference, right? There's a difference between these two electronegativities, which means the bonds itself are indeed polar. So you can say SCl bond here is polar. And when we talk about polarity, it's simply just the electronegativity difference, right? And as we know, from electronegativity periodic trends, we know that electronegativity across a period is going to increase, right? So this here sulfur is going to be less than this chlorine here. So therefore, this answer is correct here. So so the molecule itself is nonpolar, but the SCl bonds are polar. So as you can see, there's electronegativity difference. So SCl bonds are polar, but octahedral geometry makes it nonpolar in nature. So solution here is correct. Good analysis.